Alright, so let's first of all download the plugin Anemone. And as you might know, you want to first go to Food for Rhino to download any plugins that are associated with Rhinoceros and Grasshopper. And I hope you are a bit experienced with Grasshopper because the whole notion of using loops and recursions inside Grasshopper is a bit more advanced topic. So hopefully you are a bit experienced and know how to navigate around Grasshopper. But once you're on Food for Rhino, we just want to type here Anemone. And just to state, there are also other plugins that you can use to do loops and recursions. One would be, for instance, Hoopsnake, which is also used very heavily. But for this series, obviously, we're going to use the Anemone plugin. Now, if you navigate to this site, you can see who developed this plugin, and it's an open source plugin and a call that you can help them to develop this further on. And what we want to do is just basically download it. No? So we can then go to the latest release, which I think is 2015. And you just press download. This will then download the Anemone Grasshopper file. We press OK. And you can also find, I think, some tutorials, which you can find here, for instance. Yeah, but we will cover that anyway. So you can feel free to download it, but I'm not going to show it to now, right? So I'm just going to quickly show you again how to install the plugin in Grasshopper. So first of all, we would need to allocate our plugin. Now we can go to the downloads, for instance. Here's the download of Anemone. I would then just basically copy and paste it somewhere where I can find it back, put it here in my file path. And then obviously we wouldn't want to go to an open Rhino and Grasshopper file. This could be any file. And we go to File and Special Folder, Component Folder. And you just basically drag and drop it inside here. Now again, make sure to first check if it's unblocked, which that means that you go to that plugin, right mouse button click, you go to Properties and see if this box is appearing in your canvas, in your window. If so, please click that you want to allow it, right? And then you press OK. Now it's not blocked anymore and actually Grasshopper can read this. Otherwise, Anemone will not be shown. And now you just, either you just drag and drop it into this file path here, so Grasshopper libraries, which is very important, yeah. Or you can copy paste it inside here. I'm not going to do it, obviously, because I already have done it, right? If you have done it now, I would now say you can just close this. I'm gonna close everything and I'm gonna reopen my Grasshopper and Rhino canvas. And then we can start to see what actually Anemone is. Okay, so see you in the next one. So welcome to this exercise, and this is going to be the first utilization of the loop and recursion method on geometry. What we want to do is do something very simple and starting with a normal box, right? And the whole idea then is going to be that we want to always just say for each cycle, take each box that we have currently in our scene. So right now, the first iteration will only have this box, and then just make a copy and scale that box to, let's say, half the size. Always just orient or move them to my 6 individual box surfaces, right? So each box has 6 sides, and we want to now position the new scaled boxes, which are half scaled, onto the 6 box surfaces. And then as we go to the next iteration, then my new input would be not only this box, but all of my other 6 boxes also. Hence, creating in the second iteration, if I just put this here, now for each box, right, the same logic will then be recursively applied again. So iteratively, again, the box will be taken, scaled half the size, and put onto the 6 sides, right, that is. And as you go, the more complex you can get. At some point, it's going to be very difficult for your computer to actually compute, right? So be very careful and do not exceed 6. Otherwise, you're just gonna wait a long time for this to run, as I am right now. All right, so my computer didn't like the value 6 or 7 at all, so just be very careful and note that it's a bit intensive to calculate for your computer and also display. So without further ado, just let's dive into that. I'm going to get rid of everything so we can basically start from scratch, right? So we're gonna do the same thing now. And the first basic notion would be to establish the loop. I'm going to use the normal loop because I want to use the trigger just to have it as a visualization scheme also. Just gonna connect it and have already the first thing set. Now again, I want to create a slider, let's say 0 to 5. Let's limit ourselves to 5, right? And not cause our computer to crash. And I will just type iteration just to be a bit clean. Iteration, there you go. Now we want to have again a button for the trigger. And we want to set a data. And the data is going to be our first box. Now I'm going to take a very simple box method, which is the central box. You can find it, enter center box. And this will just create a center box for you. Center of that is going to be our world origin in Rhino, which is the location 0, 0, 0. There you go, 0, 0, 0, 0. And the value is currently 1. So I have a box of 1. Just going to put that into data. That's the first thing that we need to do. Now let's hard code actually the main function that actually makes up the loop logic. Now from our data output, we get basically a geometry. Just gonna use a geometry container just to show that, right? We are actually seeing this here. And what I want to do is I want to use a scale method. So I want to scale this object by a factor that I want to define, obviously. And I want to also be a bit more efficient with my center and get a volume for that. So I want to just know volume of my box, which in this case obviously is going to be the position 0, 0, 0. But as we move our boxes, it's not going to always be 0, 0, 0 or the world XY. So just centroid in center. The factor we will come into a second, but right now it's okay at 0.5. Now we want to move this new box that we just created, right, to our box sides. Outwards, that is, we want to position that. For that, we want to go to our surface tab and just first of all deconstruct the B-wrap, hence creating our faces, right? And then we want to just get normals of our faces with a very standard routine, which is the evaluate surface and the surface closest point method, right? We want to, of course, put in our UV point into point. And in a nutshell, we could just apply our faces into the surface here, and also just our faces into our surface here. And the point would be the area, right? So we calculate the area of our facade and then put that in our surface. So if you're a bit more of an experienced user, you can also avoid this kind of logic just by taking the panel and having curly brackets, that is, and then just hard coding your value, which would in this case would be 0.5, 0.5, 0, right? You're more or less establishing a position onto your surface and you just hook it up to your point, but then of course you would need to reparameterize your surface and hence you get the same output. Just for the sake of it, I'm going to use the standard format and going to reparameterize it off, right? But just note this could also be done. Okay, so we have that. What that just allows us to do is just have the normals that we need and the points. So just to show it to you, I want to now take the vector display. And we want to now take our box that we just created, the scaled box, and move it outwards into this direction. So this box should go outward in this direction, this direction, this direction, this direction. Hence creating now 6 copies more or less, right? And we can do this with the move command, right? The geometry to move would be our box, just a one item, right? And we want to move it now onto this normal here, right? This almost already does the trick. Thing is that the normal has a supplied length of the vector. We can of course change that with the amplitude, hereby getting the normal, and we can of course unitize that. And now we can play with how much we want to actually move this geometry outwards. So I could just have, let's say, a slider from 0 to 2.0, just to show it to you dynamically. 0 would be of course nothing, and then we can move it outwards, right? And we actually need to move it out by this threshold, which is 1.5. But of course, this is something very nice that you can also play with, right? We do not need to always have that very kind of flush to our surface, but we could also extend it or even, you know, put it inside the geometry that we started from. So to do that, we want to use a secondary approach, which is going to be the deconstruct box. Deconstruct box, that is. And now we take our initial box, and then what we want to do is take our scaled geometry this time, and hence we get our kind of length of the x value. Yeah, for instance, y should be the same and z should be the same because they're all uniformly scaled. Now I'm just going to take a number, right? And I get what I have here is a domain from -0.5 to 5, but if I take a number, I get the value of this domain, which is 1. I mean, okay, which is okay. But as you go along, of course, the boxes get smaller, etc., etc. So the number will also change. So that's why we need this setup. And now I can just do a division. I can take this as my main value that I want to now divide from, right? And I can again use the same slider here, put this into this realm, and then if I have 1 and put this into my amplitude. So I have now the move, and if I move everything, it looks kind of interesting. But actually what I wanted to do is to move the point which we started from. So I wanted to actually move this point that we have here, and then I want to control it with this divide setup that we just did. How much do I want to move it outwards, right? So you can see that I can control it now by this division point. And number 2 will always kind of be 0.5 in that sense. Meaning that what I can do as a last instance is just to get an orient. I mean, of course, we could have done it a bit different, but I want to show you this setup. And I want to now take this new points that I control with my move. I want to put into targets. The geometry that I want to move is my geometry. Already works. And the centroid is again coming from my volume that I did here. Yeah, so it's, of course, you could do it differently. I agree. I like this though a bit better because I can now control it very dynamically. It's kind of very flush there, but also have the capability of moving it slightly outwards if I wish that to be the case. But 2 would be kind of always the threshold that's really always kind of flush to my sides. And then we can just, make it a bit larger. So we will see that in a second how this plays out. But this is my setup actually, and I want to put it into my data, right? And get out of the loop, and this actually should already perform. So in the first iteration, this is something that will be done. In my second iteration, this will now be done also. And as you can see with my vector display, this also works, and you can see quite nicely how this has now been applied. So we can now do the same logic that we did recursively on the new objects that we created. So we are using the same function on itself in a second or third iteration, that is. Okay, in a nutshell, that's pretty much it. We can increase this now to, let's say, 4. This is something that is handleable. And then as you go along, we can see now this interesting figure. Maybe we want to get rid of our vector display. Just going to turn it off. And you can see now we have this interesting kind of method. But what we see now are only my last created items, my small boxes. So the one thing that we need to do here in our data loop end is to right click and say record the data, please. We need to retrigger it again, and hence now all of the instances will be saved also, right? And the format is kind of interesting, so you can see all of the formats are there. One thing though is that if I just put it on a preview, there you go, so it's a bit better to see. The first item is always kind of not there, right? So the first box that we started from, this guy, is kind of not in the picture, which is not bad in this sense. I actually like it and want to keep it separate because it looks much more intriguing as I go here. It's really crazy, right? So it's some kind of retro, recursive, fractal scape that we are doing there. So we want to now just progress and just use some interesting kind of custom display methods to just show it in a array fashion. So we want to now take this module and just have the different iteration steps visualized also. So that's something we're going to do in the next set. But congratulations, you did the first major job to create geometry using a recursive loop logic. All right, very well. So let's see now what actually we get out as a data output, right? Gonna use my tree viewer, my parent viewer for that. Just gonna hook it up. And as you can see, we have a very interesting kind of data format going on here. We have the iterations also displayed here with our branch count. So you can see for the first iteration, I have only one position in my branch count. For the second iteration, right, I have then my 6 branches. And as I go along, I will also add basically a number towards my branch. So I will increase the nesting of branches. What I want to do is I want to now colorize my objects depending on the cycles that they are in. So the iteration count should be mapped onto my boxes. Now the problem is, if I do a trim, let's say trim tree, for instance, and I want to get rid of all my nestings, of course it's not going to work because I have different nesting formats, right? I have different numbers, so I would also need to supply what the depth is for each branch. Now you could do that. You could also use a path mapper, which is same logic. You just do a null mapping, for instance. Yeah. And then you will see your current branches, what you have there, and then what you want to have out of that. And then you could just say, okay, I want to have for each just a branch count of 1 nesting. So this is something that you would do like so. And hence we would then create kind of this list, which I actually want. This is exactly the list format that I want, right? So I have my first iteration with 6 objects. The second iteration has that many objects, etc., etc. And you can see those are my counts. But if I change downstream my iteration count, I need to update this. Yeah? So this is not a very good method. It's not very dynamic, it is, right? Of course, there are different methods to create that, but just want to show you another setup, which is a bit more intuitive for me, yeah? And that goes as follows. I will just take a flatten. I'm gonna flatten everything, yeah? Just gonna flatten this huge list. Gonna get a volume. Going to take the volume, I get the volume as a value. I can then create a set. Going to my sets, going to get a create set out of my volumes. I get my identical values in that set. I have 5 identical values, that's beautiful. I get my create or member index. I supply my set to member index and the volumes to my set, hereby creating my new list. Yeah, so this is exactly the list that I want to have, and my indices, which I can use that to then with the list item, get my indexes and put my tree there. So now I actually have my goal accomplished. I have for each, I'm gonna use my explode tree for that to show to you. I have in my first item, my first major 6 boxes, right? That originated from this guy. In my second one, then I have my sub boxes that are then the extension of those guys, and so forth, right? Now I can basically colorize them in a very nice way. All right, so we actually have it done now. We have the count, right? We have the indexes. We could do something like the tree statistics and hook it up. We get the count here. So we have 5 loops right there. And we can get then a series, giving it the count, and now use a gradient. Now, if you use a gradient, I actually have a preset which I like for this exercise, which is this guy, but we can basically see how to do that. You just get a gradient, right? Any one that actually just features 2 colors, or you can take this one and just get rid of that guy. And then you want to change this value to something that you just go to this dot, right mouse button click. You can see my current settings, so 0.25, or you can just go here in the hue, see my value is around 50. Yeah, just add that here. So if I would do that here, just go to that value, etc. Doesn't really matter. And then I just put it to 50, something like this. And then my other value is going to be around 180 and 40. So I go here and say that's 180-ish. Yeah, and that's going to be 40-ish. And of course I want to have the full immersive, and that's it. Yeah, that's my gradient. I put my values into my parameters. I see what are my bounds. 0 is my other one bound, and then I have number 4 that I want to supply. So I take list item and get my series and get the last item that I have there, which is my number 4, put it into upper bounds, and hence I can create now a data set which has those colors. Just graph them simply, right? Get a preview object, custom preview, put in my materials, and now I want to put in my new list like so, and put it there, and voila, we should now see our nice kind of geometry in place. And maybe want to also add a secondary view, add a swatch, and take something which is a bit darker-ish here and put our initial geometry, which is this box. All right, so you can see we are pretty much there. So as the boxes get smaller, they go into the cyan color, and I can just also put in my rendered mode to make it a bit more nicer. There you go. And as we go to our smaller pieces, they get more brighter. The darker ones are the big fat volumes there, right? If you do not want to see this guy, we can also just get rid of him. And then you can see as we go in there, it's going to get more and more immersive. And I mean, of course, feel free to do whatever you want now with the boxes. You can do whatever you want with the boxes in the nutshell, right? All right, that is number one. The last thing I want to do is show you how you can now create kind of a pipeline or visualize the different cycles that this last instance went through. So the development or the evolution of recursions that it went to, and we want to just display that in the last sequence, and then we're done with good job.